Hey guys, today I want to show you an example of how to find all solutions of the complex equation z to the power of 3 equals -8. How to solve okay, z to the power of 3 equals -8 can be rewritten in polar form as 8 ei pi, which is equal to 8 ei 3 pi, which is equal to 8 ei 5 pi. Now, if you're wondering why those equalities hold, let me explain it with the complex plane. Z to the 3 equals -8 has a real part of -8 and no imaginary part. That means it lies right on the real axis at the point -8. This is z to the power of 3 here. Now, in polar form of z3 equals r to the 3 ei 3 phi. That's a generic polar form. In polar form, the magnitude r to the power of 3 is 8. That's basically the length of z3 in a complex plane from 0 to -8 has a length of 8. And 3 phi is the angle that z to the power of 3 makes with the real axis. It's just pi, you see. Now, if I keep z to the power of 3 the same length, and instead of an angle pi I use 3 pi, all that happens is that I go around 1 whole time and 1/2. And I'm back where I've begun. Same holds for 5 pi, so that's why those equalities hold. And we're going to use those to find all 3 solutions of this equation. I'm going to enumerate those. 1, 2, 3. Alright. So what we're looking for are z1, z2, z3 of the form r, e, I, phi. Where z1, z2, z3 cubed all equal z to the 3 equal -8. So let's start off with the first solution. We use z to the 3 equals 8 times e to the I pi. And now we know that r to the 3 equals 8, which means that r equals the third root of 8 equals 2. And 3 phi equal pi, which means that phi equals pi over 3. And those two combined mean that our first solution, z1, equals 2 e I pi over 3. Now, I'm going to show you what this looks like on the complex plane, and you will immediately understand why z1 is a solution. z1 has an angle of pi over 3 and a length of 2. So it's somewhere around here. This is the angle. Here, that's pi over 3, and the length is 2. Okay? So, by exponentiating z1 to the power of 3, what we do is that we multiply the angle by 3, pi over 3 plus pi over 3 plus pi over 3 puts us right on the real axis and increase the length by a power of 3. 2, 4, 8. So what happens is that we put Z1 on the real axis and change the length from 2 to 8. So it's just Z to the power of 3. Now, that's as simple as that. Secondly, Z2, what's Z2? We know that Z equals 8EI 3 pi. We know that R equals 2. It has to be the same for all solutions. And we want to find phi. We know that 3 phi equals 3 pi. That means that phi equals pi. So we know that Z2 equals 2e to the power of I pi. That's our second solution. Third solution. We know that this up here has to be Z to the power of 3. We know that Z to the power of 3 equals 8EI to the power of 5 pi. And R is 2. 3 phi is 5 pi, which means that phi is 5 pi over 3. And then we know that Z3 equals 2e to the power of I 5 pi over 3. That's our three solutions of the equation Z to the power of 3 equals -8. And if you plot this solution and this solution on the complex plane, increase the length from 2 to 8 and multiply the angle pi and 5 pi over 3 by 3, you will see that it ends up being right on the real axis with a length of 8. In other words, Z1, Z2 and Z3 to the power of 3 all equal Z to the power of 3. Thank you guys for watching. This is my first video. I hope you enjoyed it, and leave me some comments. Thank you.